Okay, so last section we'll look at this week is 4.3. It's on Law of Cosines. And so far we've looked at how to solve three kinds of problems. We've looked at angle, angle, side, angle, side, angle, and side, side, angle. The first two are very straightforward. Okay, you always have one solution. You never have to worry about the two solution, no solution. Side, side, angle is the case that you have to do all the two solution stuff. There's two types we haven't looked at yet. We haven't done side, angle, side, which is what this is an example of, and we haven't done side, side, side. When you're looking at the table, what does the table have to have? And if it has this, you know right away it's law of sines. Yep? It has to have a complete row. Or if it doesn't have a complete row, maybe they give you 2 out of 3 of the angles, and once you get the third angle, then you have a complete row. But looking at this one, do we have a complete row? Jordan? No. No, there's no complete row, and there's no way to find a complete row. You're missing 2 angles, so you can't add up 2 angles and subtract from 180. That's not going to work. And can I use Pythagorean theorem to get C? No. If I could, then I would have a complete row. But if I use Pythagorean theorem, what am I assuming about the problem? I'm assuming that it has a right angle, and I don't know if alpha or beta are a right angle. I'm not sure. So I can't assume that. So this kind of problem falls under a different formula, and it's the law of cosines. So we've learned the law of sines. We're going to learn law of cosines. There's also a law of tangents. I honestly don't really know a lot about it. Might not even have to do with anything we're studying at all, because law of sines and cosines covers everything. So law of tangents, I think, is something different. Okay, but I did find it in a really, really old math book once. Okay, so law of cosines is used to solve 2 types. Side, angle, side, which is what you have an example of right there, and side, side, side. So on the left is an example of side, angle, side. So you know 2 sides and an angle. And we've done that before, where you know 2 sides and an angle. But the difference is where the angle is. Before, the angle was not between the 2 sides. Now the angle that you know is where the 2 sides come together. And side, side, side. Okay, that's on the right. One type that I didn't put up through any of this was angle, angle, angle. How come? Why would it be impossible to do angle, angle, angle? Yep?
Because they can all be the same angle, but you don't know what scale, like how big or small the triangle actually is.
Yep. You always have to have a side to give you a scale. Say, for example, I said to you, I'm thinking of an equilateral triangle. All the angles are 60, 60, 60. How big is each side? Well, they could be 3, 3, and 3, or 20, 20, and 20. They're all the same, but you don't have a side for scale, so that's why we never deal with angle, angle, angle. Okay, for this formula, we're not going to go through the proof. The reason is that it requires something we haven't learned yet, called Trig Identity. So like the law of sines, it has kind of 3 parts to it. It's not fractions, but you'll see what it is in a second. A, B, and C are going to represent our sides. Alpha, beta, and gamma, those are our angles. So it starts out like that, at least one version of it. Okay. There's a version that starts with C squared, B squared, and A squared. They all follow the same pattern. Let's start out with the one that has C squared. What does that kind of look like? Actually, what does that look like exactly? It looks like the Pythagorean theorem. But we already know earlier, I said you can't use the Pythagorean theorem, so there's got to be a little bit more. So it starts out looking like the Pythagorean theorem, but then we subtract something. We're going to subtract 2ab cosine gamma. Okay, so let me go through it, not reading the letters, but just describing the pattern. And if you understand the pattern, then you can figure out the other two versions. One side squared equals the sum of the other two squared minus twice the other two, the letters you just used right before it, and then it's the cosine of the angle across from the letter you started with. So one side squared equals the sum of the other two squared minus twice the product of the other two, cosine of the angle across from what you started with. So technically you can call your sides XYZ, HIJ, you can call them whatever you want. We use ABC, but it's good if you just kind of understand the general pattern, especially in a word problem if they don't label things the way you're used to. All right, so anyone think they could start me off with the version that begins b squared? Nate?
Would it be b squared plus a squared?
Yep, we just put it in alphabetical order, but that's fine. So b squared equals a squared plus c squared minus, anyone think they know what would come next? Yes?
2AC.
Yep, 2ac cosine of the angle across from the letter I started with. So it would be cosine of, Brady? Beta. Yep, cosine beta. Okay. And is that a different law? No, it's the same law of cosine, it's just looking at it from a different perspective. And then we'll write out the last version. Okay, so it starts out a squared. And Tanner, I think you could tell me the next part?
B squared plus C squared.
Yep, b squared plus c squared minus, well, Colby, what do you think would come next?
2BC.
Yep, 2bc times the cosine of the angle across from the letter we started with,
Alpha.
alpha. And I could write it again if you wanted to call the sides x, y, and z. I could write x squared equals y squared plus z squared minus 2yz cosine of whatever your angle is. So you can keep writing it with as many different letters as you want. Okay, but that's all I'm gonna do. Just for referencing them when we do problems, I'll ask you which version should we use, 1, 2, or 3. You don't have to call them 1, 2, and 3 in your notes, just that's easier for me. Any questions on the formula? All right, so let's look at some examples. That's all you really need to know. I'll do one side, 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 one side angle side, and then probably one word problem. Okay, I think this is the same one I put up to start the notes. Yep, 2, 3, 60. All right, first thing I'll do, I'll make a sketch just so you can see what type it is. Although from looking at the table, you should already know whether or not law of sines is going to work here. Okay? But on the test, you'll have to figure it out. So I'm going to show you how to figure out if you should use law of sines or cosines from a picture. And then we can mention again how you tell from the table. So I'm going to put A, alpha, B, put beta across from it, C, gamma. So Kyle, based on that picture, what kind of triangle is this? Using our 3 letters.
Sorry, I don't know.
Not sure. Yeah. You know a side, you know an angle, you know a side, and the angle is where the two sides meet. Clearly my picture is not to scale, right? So don't look for that. But if you go back in your notes, side angle side is law of cosines. Tried to make a chart kind of here. I'm not sure if people copied it or not. Those two are law of cosines. Those three are law of sines. Okay, so there's how you can tell from the picture. How can you tell from the table that this is not a law of sines problem? Yeah?
There isn't a complete row.
There isn't a complete row. So if you try to set up law of sines, watch what happens. Pick two rows. You got to use two, any two you want. Let's use the first two. Sine of an unknown over 2 equals sine of an unknown over 3. That's a problem. You have two unknowns. It's not going to work. Pick the last two rows. Sine of an unknown over 3 equals sine 60 over an unknown. You have two unknowns again. Okay. No matter which two rows you pick, you're always going to have two unknowns with law of sines. Okay, so we got to do law of cosines. In a side angle side problem, you have to solve for something first. Okay, so you either have to use version 1, 2, or 3. Anyone think they know which version we're going to use first? Yeah?
3.
Yeah, we have to use 3 because if you look at all the different versions, they all have every letter. There's an A, a B, and a C in every version. We're already missing C, so that's something we're missing. We can't be missing anything else. If you tried to use version 1, let's see, yeah, well actually let's go with version 2. If you tried to use version 2, you're missing C, and you're missing beta. That's no good. And what version did you say?
3.
3? All right, let's try 3. We're missing C. We don't know that. And we're missing alpha. No good. So we can't use version 3. Let's look at version 1. We're missing C. We've got A. We've got B. We've got A. We've got B. We've got gamma. That's the one to go with. Okay. So we're just going to plug everything into that and see what we got. So C squared. The first time through, I won't skip steps. I'll show every step out. So A squared plus B squared minus 2 times 2 times 3. That's 2AB. 2 times 2 times 3. You really don't need parentheses there. You can put them if you want. It doesn't change PEMDAS or order of operations. It's up to you. Times cosine of 60. All right, so if we're going to strictly follow order of operations, we always do all our multiplication first. So, or actually we do exponents first. Let's do that. So 4 plus 9. Now I'll do my multiplication. Ethan, what's 2 times 2 times 3? 12. Cosine 60. Okay, I'm still not done with multiplication. I have to do 12 times cosine 60. All right, let's do that. 12 cosine 60. Cosine 60. Okay, the cosine of 60 is 1/2. So 12 times a half, that's how we get 6. So C squared is 4 plus 9 minus 6. Now we do addition and subtraction in order from left to right. So C squared, 9 plus 4 is going to give me 13. 13 minus 6, 7. Now that's C squared, so what do I have to do to get C? Yep.
On the square root of 7.
Take the square root of 7. And for most of these answers, in fact, all of them, we're going to round it off to 3 decimal places. Square root of 7, 2.646. Okay. now I have C. Any questions on that? Okay, I'm going to label that in my diagram. And now, besides being a side angle side triangle, I'm going to ask you what it is with this extra piece of information. What other kind of triangle is that now, besides SAS? Good?
Side, side, side.
Yeah, it's a side, side, side. So we could look at it from that perspective. Side, side, side still falls under using law of cosines again. What other kind of triangle is it? One more type. Yep.
Side, side, angle.
Yeah, there's a couple ways you can look at it, but it's side, side, and an angle that's not between them, or side, side, and an angle that's not between them. Well, the problem with looking at it as side, side, angle is that's the one where we have to deal with all the two solution and no solution. So if we tried to use law of sines, we could, if we were very careful and did it right. But the easiest way to do it is to finish the problem the way you started it, with law of cosines. Okay? That way, law of cosines will give you the one correct answer automatically. You don't have to think about all the two solution stuff. Okay. So at this point, we know A, we know B, and we know C. We know everything in every version of the formula up to right there. So you can pick whatever you want to do at this point. Solve for alpha, solve for beta. Doesn't matter. Okay. But once I get alpha, I'm going to do beta the quick way. I'm just going to subtract alpha and gamma from 180. Right? If I really wanted to practice more law of cosines, I could do it twice. And I could find alpha and beta totally separate. Meaning if I made a mistake on one, it might not affect the other. Okay? So that's an advantage. Disadvantage is going to take longer to do that, because you're going to have to do it twice. Okay. So let's finish it up by just doing it one more time. And let's find alpha. Okay, so alpha is version 3. A squared equals b squared plus c squared. So a squared, and I'm going to do it as I go. So a squared is 4. Can someone remind me, what was b? 3. So a squared equals b squared plus c squared. Well, I've got c squared right here. C squared is 7. I got that from the work in the previous step. So if you can do that, that's better, because if I take the square root of 7, which was what, 2 point something? 2.646. If I square that, I'm not going to get 7. I'm going to get like 6.99 something. All right, but I know the answer to c squared should be 7. All right, so we got a squared equals b squared plus c squared minus 2 times b times c. Well, 2 times b was 3. No b was. So 2 times b times c. Was it 2.6 what? 2.646. 2.646. So 2 times 3 times 2.646, 15.876. And then the last thing, cosine of the angle I'm trying to find. So in that one, I kind of did a few steps as I went. I squared everything, and I multiplied it all together. Okay. What's the next thing I could do on the right side? Still some like terms I could put together. About Abby?
You could add 9 and 7.
Yep, we can add 9 and 7. So we get 4 equals 16 minus 15.876 cosine alpha. Now you have to be careful at this step. Okay, it's not a hard step. A lot of people don't follow their order of operations when solving an equation. What would be the next thing I would do on this problem? Cassandra?
15.876 cosine.
Okay, so if we had a value for alpha, we've got some multiplication here, we would multiply it. But think of this as it's a variable. So we have a variable times a number. There's not really much I can do with it since I don't know the variable. But if I knew it, I would have done that at this point. Any other thoughts what I should do next?
Subtract 16 from both sides.
Yes, subtract 16 from both sides. What some people try to do is 16 minus 15. You can't do that. Okay? Pretend this was your equation. 4 equals 16 minus 15 times something you don't know. 16 and 15 aren't like terms. So you've got to subtract the 16 to the other side. Same thing here. Okay, so let's do that. Subtract 16. 4 minus 16 gives me negative 12. All right, now I've got 2 steps left to get cosine alpha by itself. I got to get rid of the number, and then I got to get rid of the cosine. Okay, how do I get rid of the number? Yep.
Divide it both sides.
Yep. We're going to divide both sides by the negative 15.876. The number cancels, the negatives cancel, and on the other side, the negatives cancel. So now I have 12 over 15.876. Now, at this step, just look at what you have. If you don't have a bigger number in the bottom, then don't even go any further. Something's wrong. Okay? Because to take inverse cosine of whatever that is, it has to be less than 1. So if you don't have a bigger number in the bottom, this fraction is not going to be less than 1. This one's good. 12 divided by 15, bigger number in the bottom, it's going to come out to less than 1. So I'll get an answer. All right. All of the problems we do today have answers. There are none with no solution. Okay, so my last step. Just like we did with law of sines, to get rid of the trig function, use the inverse. This time it's inverse cosine. And inverse cosine. All right, so second inverse cosine, 12 divided by 15.876. So we get an angle of 40 point, technically that would round up to 40.900 if we're showing the accuracy. Okay, I'll just copy that up in my table. Okay. Now, again, to get beta, you could do the same thing again with law of cosines. Or at this point, I'm just going to add up the 2 that I have and subtract from 180. So 180 minus 60 is 120, minus 40.9. And again, showing the accuracy, that's 79.100. I'm just going to check real quick. Biggest side goes with the biggest angle. Smallest side is with the smallest angle. Looks good. Questions on side angle side? As far as law of cosines, this is the best one to do because it involves both types of things that can happen. It has the type where the letter is already by itself on the left, and you don't have to use inverse cosine at all. That's the first thing we did. The second thing that can happen in law of cosines is where the letter is on the right, and you have to use inverse cosine. Other than the 2, I guess you call them procedures we just went through, that's it. That's the only 2 things that can ever happen with law of cosines. And on side, 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 only one of them comes up. You do the same thing a couple times. You're never going to have to solve for a side in side, side, side. So you're never going to be doing anything like that in this problem. Taking the square root at the end? No. What we do this time is going to be like that stuff. Okay, so we need all three angles. Which version of the law of cosines would I have to use first here? Version 1, 2, or 3? Oh, 3? You can use any of them. Yeah. If you look at the versions, you know everything you need to know in every formula because you have all the sides. The only thing you're missing is the angle. So we can use any of them, but at a minimum, how many times are you going to have to do law of cosines here? You're going to have to do it twice. What you could do, if you had extra time, you could do it 3 times, and then you could find every angle totally separate, which means if you make a mistake on one, it would have no effect on anything else. If you do it 2 times, you're going to save yourself a little time, but the downside is if you make a mistake on one and you use it to get the third one, then that one's going to be wrong as well. Okay. So let's use a version we haven't used yet. We did alpha. Let's do beta. Okay. So to find beta, how about Jamichael? Can you tell me how my law of cosine starts off? To find beta.
Sine.
So we got to use law of cosines here because we don't have a complete row. So I didn't really mention that in this one, but again, there's no complete row, so we have to use law of cosines.
So I guess it is number 2. B squared equals
Yep.
A squared plus C squared.
All right, b squared.
2
Okay, hold on, I can't do math that fast. B squared equals a squared plus c squared. Yep, go ahead.
Cosine beta.
And what was right after the minus sign, Michael? Minus
2AC.
2ac. 2 times 4 is 8. 8 times 6, 48. And then he just told me cosine beta. And what's nice about side, side, side is if it's all integers to start with, you're not going to have any decimals in the whole problem until the very end. Okay, so no decimals here. Okay, so we can add the 16 and the 36. 16 plus 36 gives me about Alan, what's 16 plus 36?
What was that?
16 plus 36.
52.
52. Minus 48 cosine beta. Okay, my next step, and here's where you got to be a little careful. Lauren, what's my next step?
Subtract 52.
Yeah, subtract 52. Don't do 52 minus 48. You can't do that. Those aren't like terms. So minus 52. Minus 52. So we get 9 minus 52 is negative 43. And at the same time, just to avoid rewriting this whole thing again, how would I move the negative 48 to the other side? Divide. Yep. So I'm going to divide by negative 48. Negatives cancel. And then my last step to get rid of cosine. You remember how we got rid of sine? It's the same idea. Exactly, yep, we're going to take the inverse. So, take the inverse on the right, take the inverse on the left, and that is your answer for beta. And that's an exact answer. That's not approximate. It's going to be approximate once I round it off. But I'm going to check real quick. Bigger numbers in the bottom. I know 43 divided by a bigger number is going to come out less than 1. So that's a good sign. Inverse cosine, 43 over 48. And beta is 26.384. Okay. Any questions on that one? So my advice at this point would be just use law of cosines one more time to do alpha or gamma. Let's at least set up the equation, and then if people don't need me to go through and solve it, I won't, but we'll set it up.
Can we do alpha?
Yep, let's set it up for alpha.
Set it up and the calculator substitute for whatever.
Okay, so we've got a squared equals b squared plus c squared. So a squared equals 9 plus 36 minus 2 times 3 times 6. I'm going to do that part in my head. 2 times 3 times 6, that's 6 times, 2 times 3 is 6, times 6 is 36. All right, so we've got 16, and then I'll just go a couple steps till we find your mistake, Alan. What did you do next at this step?
I already found the mistake.
Oh, you found it?
Yep.
Okay. Did anybody need me to finish it up from there? There's 3 steps left. Minus 45, divide by negative 36, and then inverse cosine. Which if you wanted, you don't even have to do any of that out. You could just say, all right, minus the 45, divide by the negative 36, don't even worry what it comes out to, and then take inverse cosine. Just leave it like that. Type it all in. Okay. Any questions on how to finish it from there? Now that we've basically done the whole thing. Okay. Does anyone have the answer for alpha? You just save me a minute. Yeah.
36.336.
36.336. Perfect. And now gamma, 2 options. Do law of cosines again. That's the safe way. Mistakes don't propagate that way. Quick way, just add these up and subtract from 180, which is how I'm going to do it. Did anyone add those together? Subtract from 180 and get that answer? Yeah, do you have it?
I did the problem. I got the
You got it. Okay, what'd you get?
117.279.
117.279. So you did the whole thing out using law of cosines a third time? Okay, so that's a good way to check it. If she did it with law of cosines, let's double check that they all add up to 180. So we get that, 26.384, and 36.336, 179.999. That's just because of rounding. So that's good. So since I got the same answer adding up to 180, she got it using law of cosines. Pretty much guarantees it's right. Any questions on that? All right, so last problem. All right, so this one's going to be about finding the distance between 2 objects that are in front of you. Okay. We're not finding like the height, but we're going to find out how far apart they are. So maybe you're looking in the distance and you see 2 mountain peaks and you want to know how far it is from one to the other. If a bird was flying. So we're not going to have 2 mountain peaks. We'll just say 2 houses. This one's going to require a picture, but basically what's happening is a surveyor is standing at point C. There's a house in front of them on one side that we'll call house A. There's a house over in front of them, house B. So it makes kind of like a triangle. House A and B are in front of you, and you're standing at point C. Using a transit or whatever device you have, the surveyor measures the angle from house A to house B to be a 70-degree angle. Okay? It's like if I'm standing here and point lasers at two houses, the lasers meet at a 70-degree angle. Okay. The surveyor walks the distance from where they're standing to house A, and then from where they're standing to house B. So if you're wondering, well, why don't they just walk between the houses and get the distance directly? It could be that maybe one house is on each side of a canyon, right? And the canyon kind of comes together where you're standing. So you can walk to one side of the canyon, get the house, you can walk to the other side, but you can't walk between. Okay, it could be a river, or whatever's between the houses. And I want to know how far apart the houses are. All right, so again, there could be all kinds of reasons why you can't walk directly between the two houses. In our particular problem, it's going to be because there's poison tree frogs. All right, so poison tree frogs between the houses, you can't walk between them. It's no good. So there's our two houses. And what I wanted to do was find a surveyor, just to kind of have them at point C. I couldn't find a surveyor in the pictures, but I was able to find a World War II trench soldier. So that's our surveyor. Pretend. So there's our surveyor at point C. All right, so the goal now is to find the distance between the two houses. How far was it from the surveyor to house A? What did the problem say that was? 50 feet. How about from the surveyor to house B? 70. And angle ACB was how much? 70. Just a coincidence, 170 feet, 170 degrees. Side, angle, side. SAS. So that's a law of cosines problem. All you really have to do is find x. We'll call it A. Well, don't call it A or B because you already used those. But call it something. I'll call it x. Okay, anyone think they can set up the law of cosines for me using the four things that I have circled? I want to start out with the idea one side squared equals the sum of the other two squared. How about Cole? Could you start us off with that?
Does it matter what one we do?
Well, you can't really use any of the versions that I wrote because nothing here has an A, B, and C in the formula, so you just have to use the general idea.
Would it be, I don't know.
Not sure. Ryan, can you help him out?
C squared equals.
Where's C? Oh, you're using the C? Remember, the first thing is the sides. So the way the book did it, they used letters for the angles. So we have to use the general idea. Forget about A, B, and C, though. Because we won't have an A, B, and C anymore.
X.
Yep, X.
Equals 50 squared plus 70 squared.
Let's start out X squared equals.
Wouldn't it be 50 squared
Mm-hmm.
plus 70 squared?
Yep, that's good.
250 times 70.
Yep, anything you want to put right before that?
Minus.
Yep, minus 250, 70. And one more thing, and then we're good.
Cosine X.
We already used X.
C.
And what is C? We know that.
70.
70. So one side squared equals the sum of the other two, minus twice the other two, times the cosine of the angle across from what we started with. And now we just plug it in and see what it comes up to. Some of this we could kind of do a little bit in our head. What's 50 squared? How much is that? Yep, 2,500. 70 squared, 4,900. What's 2 times 50 times 70? Yep, because 2 times 50 is 100. 100 times 70 is 7,000. Or normally we say 7,000. Cosine 70. Justin, anything else I can still do there before I need my, my calculator? Yeah, you can add 2,500 and 4,900. That's 7,400. The rest, though, I need a calculator. Before I even type it in, what I'm going to do is just get x by itself. Okay, how would I get rid of the square? Yep.
For root 7,400.
The whole thing.
Oh.
7,400 minus 7,000 cosine 70. Okay, now I can just type that in, or if somebody already has it, that would be wonderful. Does anybody already have what it comes out to? Sean's working away. Let's see. So you got it. Let's see if Sean gets the same thing. All right. What do you think? You got it, Sean?
No.
No? Maisha, what'd you get?
70.752.
70.752. Is that what you got, Joe? All right. So 70.752. That's the distance between the houses. Okay. All right. So as far as material for the week, we're pretty much done everything I need to show you for the test. The test will be 6 questions. Each question will have 3 parts, finding what you need to find. One question will have 4. That will be a side-side angle question. And tomorrow we will review. Okay, homework, it's on 274. And it's 9, 11, 13, 17, 25, 27. Okay, also, don't forget my extra help will be after school today. So if you need to get anything done before grades close on Friday, that's the last chance to do it after school with me. And also this week's test is going to go on term 4.